All right, fantastic. Hello, everybody. Thank you for joining us today for this special webinar, joint webinar event focusing on serverless monitoring and migration. Our speakers today will be Ryan Jones, founder of Serverless Guru, a cloud consultancy that specializes in leveraging serverless to accelerate development and reduce operational overhead. Outside of work, you can find Ryan spending his free time learning Spanish, hitting the beach to catch some waves, and playing poker. Our other speaker today is Chinmay Gaikwad, a technical evangelist at Epsagon, a company which helps clients monitor containers and serverless environments. He is experienced in Kubernetes, cloud technologies, and data center products. In his free time, he loves traveling and exploring new restaurants, and I do as well. If you have any questions throughout the presentations, please feel free to put them down in chat or in the Q&A section, and we'll get to them at the end. This is my part of it, and I think I'm going to hand it off now to Chinmay for his talk on observability for Lambda applications using distributed tracing.
Thanks, Jonathan. Let me just share my screen. Yeah, thank you for having me. And for all those attending this event live, thanks for being here. This talk is essentially about end-to-end observability for Lambda applications using distributed tracing. My name is Chinmay Gaikwad. A bit about myself. I'm a technical evangelist here at Epsagon, where I help developers find out solutions about how they can achieve end-to-end observability for the microservices-based environment, be it Kubernetes or serverless environments. In my previous life, I have been a software engineer, an applications engineer, and technical marketing engineer. So a bunch of different roles at companies big and small. The picture on the right is something that I'm really passionate about, which is traveling. I love traveling. And this picture particularly is from a place called Sapa in Vietnam. It's one of the most beautiful places I've been to. So if you haven't visited Sapa, I highly recommend it. So if you have any questions about observability or serverless or traveling, you can reach out to me at the handles given here for Twitter and LinkedIn. So with that, let's get started with our session. So in today's session, we'll see how the evolution of microservices and serverless functions have happened over the past decade. And then we'll look at why we need a new observability outlook because of these changes. Finally, we'll see how we can use this to figure out the observability solutions using distributed tracing. So let's get started. So as most of you might know, hand in hand with the evolution of software, there has been a massive shift in the architectures world as well. Today, almost 85% of the enterprises are adopting microservices as their primary architecture. You might have observed that the highly distributed modern applications are not built in data centers anymore, but they are built in the cloud. These modern applications can be thought of as mini apps, each application independent of each other and lightweight. Microservices architectures have great benefits, but these simple to represent monolithic architecture diagrams have started to become much more complex because of the microservices change. Similarly, over the past decade or so, we have seen the rise of serverless as well. Earlier, applications were built very close to the hardware or bare metal. So in those days, it was pretty fun. You would want to ship the hardware to your place, either dock it yourself or use professional services, install the operating system, figure out the networking, and then you could get to application coding. But over the years, we have seen this cycle reduced by quite a bit. So we saw the rise of virtual machines. Then we saw the rise of containers and Kubernetes. And finally, we are here in the serverless world. As you can see, from left to right, the application has gone farther and farther away from the actual hardware or bare metal. This is an important point to note, as it will come up in the upcoming slides. With serverless and microservices, we have seen most of our customers or all of our customers benefit hugely. For example, Vonage now releases features twice as fast with half the effort. Choco, which is a small startup, has pivoted during COVID and doubled its valuation. So as you can see, the benefits of microservices are not restricted to a particular industry or a section or a size of a company. You can see the benefits throughout. But as Werner Vogels once said, everything fails all the time. And I completely agree with it. So if things fail in the microservices world, since microservices are much more complex, it becomes really hard to find where exactly the problem is happening and to fix them. More specifically, we have seen a lot of usage of cloud service APIs, such as AWS APIs or GCP APIs or Azure APIs, along with third-party APIs such as Stripe, Twilio, or Auth0, and this adds to the complexity. We have also seen a lot of our customers deploy thousands of containers or serverless functions, which don't show a particular behavior. They show a wide variety of behaviors. That further adds to the complexity. And finally, one of the most important things that have happened from the shift of monolithic to microservices world is that the logic of the code has shifted from within an application to the calls between microservices. This is a very important point to note. In terms of business impacts, we've seen almost 3/4 of issues being found by customers before they are discovered by the operations team. It has become increasingly difficult to root cause these issues in a distributed world. Also, every minute of downtime costs companies around $8,000. These are huge numbers. So how do we reduce these numbers? Well, observability can definitely help in a significant way. Let's take a pause here and see what observability exactly means. Observability can be thought of as 3 pillars: metrics, logs, and traces. Let's start with metrics. Metrics are a great way for operations to figure out if something has gone wrong. Some examples of metrics include CPU usage or memory usage, or you even have business level metrics such as click-through rate or bounce rate. Logs, on the other hand, can tell us why something went wrong. But when you have hundreds or thousands of such microservices, these alone are not enough. We'll get into tracing a bit later. So why do we exactly need a new observability outlook? If you saw traditional APMs or observability solutions, they actually focused on looking within the service. That is because they were focused on observing monolithic applications. But as I mentioned before, the logic has shifted from within a service to between the services. So that's where they kind of miss. Also, traditional APMs are built using heavy agents, which need to be manually instrumented. These agents really don't work in a cloud world where heavy agents can consume a lot of costs. As I mentioned before, earlier applications were built closer to bare metal, so infrastructure monitoring was highly important. But as applications have moved away from bare metal, infrastructure monitoring has become less important. So application monitoring has become much more important in this case. Log aggregators do help in some sense, but logs don't really work as a starting point in a highly distributed world. Let's see why with a simple use case. So for this session, I have a simple use case of a virtual shop where users can send orders for items. As you can see, the HTTP server authenticates requests using Auth0 and then pushes them to the Kafka stream. Another Java application pulls a stream and updates the orders on the DynamoDB table. Let's say there is a scenario where users complain about orders that were sent but not handled. So where would we start? Generally, we would start by looking at different dashboards for different microservices. Here is an example of a Kafka metrics dashboard. As you can see here, there are different graphs. All of them seem normal. We don't see any abnormalities. So we would like to move to a different microservice. So let's move to the DynamoDB dashboard. As you can see here, there are spikes, and these spikes are very important because they are the count of user errors. But why do we see these spikes? That's where we need more data. And traditionally, when we need more data, we kind of look to logs. But as I mentioned before, logs really don't work as a starting point. That's because imagine your application having hundreds or thousands of microservices, and each microservice producing hundreds of thousands of log lines. So you'd have to look through a lot of log lines to get to the root cause of the issue. And as I mentioned before, each minute of downtime costs companies thousands of dollars. So that's not really the efficient way of doing things. That is exactly why I have a love-hate relationship with logs. I love the fact that they are available, but I hate going through them. So in our use case, if you're lucky and if you spend a lot of time, you'd see that the key is missing in the Java logs, but it's still incomplete. So let's take a pause here and see what are the things that I'm missing. The things that are missing are the correlation between metrics and logs and between different microservices. Most importantly, we need to figure out where something has gone wrong and how can we fix it. That's where distributed tracing comes into picture. Before we get into distributed tracing, let's see what a trace means. A trace essentially is a flow of user requests through different microservices. Just because your application consists of tens or thousands of microservices doesn't mean each request flows through every one of them. At most, it goes through a subset of those microservices. Distributed tracing is essentially correlating different traces together. So for example, here you have 3 different traces for 3 different user actions. One of them starts at an HTTP endpoint and either ends at S3 bucket or an auth0 microservice. And the second one starts at the S3 bucket and ends at a DynamoDB table. So with distributed tracing, you can correlate these different individual traces together to form a single trace like this. This gives you a lot of data, and also you can use this for debugging. Distributed tracing has great benefits. Let's see how you can use distributed tracing to troubleshoot your serverless applications. One of the most important benefits of distributed tracing is that you can actually create a holistic view of your architecture. We call these service maps. I've seen developers use service maps during the design phase and the implementation phase as well. Service maps are essentially used in implementation phase. For example, when you want to release new features, you can see how new microservices interact with the current ones and if that is the expected behavior. It also helps architects design their applications more efficiently and effectively. Another great benefit of distributed tracing is it can tell you where exactly your code is spending time. This can be done through something called a span. A span is basically a unit of work which and many spans accomplish a trace. So with a trace or a span, you can find out whether you have some external API call waiting to respond, or whether you have a database that is inefficient and consumes a lot of time, so it needs refactoring. So using a timeline graph like this, you can actually figure out where exactly the performance and latency issues are happening. As I had mentioned before, the correlation between metrics and logs was missing in the traditional approach. With distributed tracing, you can actually correlate metrics and logs together. So you get contextual logs along with the metrics that are relevant to that particular issue. Alert fatigue is another thing that can be addressed through distributed tracing. These days, as most of you might know, you get a lot of different alerts and not all of them are important. Because trace data is so huge, you can actually use that data to contextualize and configure your alerts. So you can go into minor granular details about what exception type you want or what error code you want, and that basically pops up at the top of your list. And then you can figure out on the important alerts rather than focusing on all alerts. Similarly, you can do a same exercise with different visualizations. I've given an example of errors and exceptions here. So as you know, not all errors are the same. For example, a user being rate limited is important information, but it is not as critical as seeing a huge number of 500s. So you would want the trace data to slice and dice the visualizations in n number of ways so that you can focus on the important ones. Same is true with exception type as well. You would want to focus on the exception type that is important for your applications rather than focusing on all exception types. As I mentioned before, a trace essentially is a flow of user requests through a subset of microservices. So you can bring focus to the problems using a distributed tracing based approach. This basically takes down the guesswork that is required to figure out where exactly the problem is happening. And it gives you a few microservices where you can focus all your efforts on while troubleshooting. And another important benefit which Epsagon does is the payload information. As I mentioned before, the logic of the code has shifted from within an application to calls between microservices. So it is really important to know what information is being transferred between microservices. So payload information in this case can help greatly to reduce mean time to detection and resolution. So let's revisit the use case with all the things that we have seen till now. So as you can remember, we saw a case of virtual shop where users were supposed to send orders for items, but users were complaining about orders that were sent but not handled. So using a distributed tracing based approach, you can filter down on traces that have errors in them. Once you click on a particular trace, you get a nice distributed trace where you can focus on different microservices. So let's start with a DynamoDB microservice as shown at the bottom here. Here you can see that the key ID is missing. Which key ID though? Once you focus on the Kafka microservice, you can see that the username is missing. But again, why is the username missing? Once you focus on the auth0 microservice, you can see that the JSON token has expired. And now you know that you should have used refresh tokens instead of access tokens in this particular example. So as you can see, within a few clicks, you can actually detect the problem as well as find a solution for the problem. So this reduces your MTTD and MTTR by quite a lot. At Epsagon, we believe that an observability solution can help you throughout your engineering lifecycle. With service maps, we saw that you can use an observability solution during design and implementation phase. Whereas with trace data, you can use that data during testing and production phase to troubleshoot your applications very quickly. So observability need not only come in the production phase, it can be a part of your entire development cycle. So that's all I wanted to share for this session. Let's go through a quick summary. So initially we saw how microservices-based applications have their own unique benefits as well as challenges. We saw the challenges with respect to observability. We also saw the advantages of using distributed tracing-based approach. And we saw how your distributed tracing-based approach can help you keep track of your architecture as well as troubleshoot issues more effectively. I'd like to say that you should adopt an observability solution that helps you shift your mindset from being reactive to being proactive. So thank you for attending the session. If you have any questions, I'd be happy to take them now or at the end of the session. We have some giveaways at this URL given below. And if you have any questions about this or any other serverless or observability based stuff, please feel free to reach out to me at my Twitter handle. Thank you again.
Awesome. Thank you so much, Chinmay. If we have any questions, we could feel free to take those now, like you said, at the end of this session. So if anyone has any questions or anything like that, feel free to ask. That was a fantastic presentation, Chinmay. Thank you so much.
Thanks.
Yeah.
Perfect. All right, well, getting into the second talk today, we're going to be talking about going serverless. So let me open that up here. Perfect. Okay. So getting into the core of this talk, as you can see underneath the title there, going serverless, serverless acceleration team. And so kind of the way that this talk has evolved over time is that we almost have what's typically called a cloud acceleration team, and they basically help the organization adopt cloud. And so in this way, we're talking about a serverless acceleration team, which is a team that you can build either internally at your company, or you can add other people from outside of your company to integrate in and then kind of replicate these types of efforts. And so that's what we're going to be talking about today. First off, just a little context. What Serverless Guru does is we help companies innovate faster, reduce operational overhead, and streamline application development by leveraging serverless technologies. What that looks like is that because of our years of experience doing this and helping many clients, we can help you skip over the complexity, lay a strong foundation, and then get closer to the benefits of serverless a lot faster. Some background about myself. As you can see, I just recently took a photo during the webinar while Chinmay was talking, which is fun. As you can see here, founder of Serverless Guru, started back in 2018. There was a gap in the market for serverless consultants, and it just started as like one person and then slowly grew over time. And now we are up over 20 people total in size, and we have people in 10 plus different countries. And I want to say we're almost on every continent now, which is pretty insane. Also, the co-host of the Talking Serverless podcast and author of Serverless Zero to Paid Professional, which is an online course that has around like 95 videos about building serverless applications. And you can find that on our training.serverlessguru.com URL. And also an AWS community builder, which I am repping today on both of these things. I'm having to cool the apartment down quite a bit because here in Puerto Rico, it is not cold. So this is the only time that I can wear something like this. Otherwise, it's t-shirt and shorts for me. My serverless journey started in the innovation engineering department at Nike. And as I mentioned, Serverless Guru started around late 2018. Again, I live in Puerto Rico now, and kind of a weird change for me growing up in Texas and then living in Portland, Oregon for a long time. I surf almost every day now, and that's been the same for about 4 to 6 months now, which is great. So the first thing I want to jump into is similar to how Chinmay kind of got into like an overarching theme of how we got to where we are today. And that's with the cloud spectrum. And so the cloud spectrum, I'm going to start with on-prem. And so we basically, maybe you had your own data centers, things like that. And then we moved to virtual machines, and with virtual machines, things like AWS EC2. And so you would run your application, you had to manage a lot more of it. You had to patch it, you had to have installation scripts and all this stuff. And so the complexity level to even get something running was a lot higher back then. And then we have containers, and there's a little bit more tooling, a little bit more nuance. You can take some of that idle time of running a server and kind of chop it into smaller parts, and then you use it more in an optimal way. And then that kind of led to cloud functions and what we're calling serverless in this case. And so cloud functions is kind of that layers of abstraction that Chinmay was talking about. And so all those things still exist, right? There's still a data center, there's still virtual machines, there's still containers, and there still is cloud functions. And so we're now operating at the level of I write my code, I deploy it, and I start doing really cool things right away. And ultimately to our customers, that's the only thing they actually see. And arguably the only thing they care about is when I'm viewing your website or interacting with your service or product, am I actually able to do that in an effective way without delays and things like that? And if you are able to achieve that with serverless, then they wouldn't know if there was a server in the background or a data center, or if your wiring was super good, all that's abstracted. So how do you go about this from the perspective of, let's say you're going to dive into serverless. So let's start off with a basic question, which is, does your team already have serverless experience? So if they do, then you want to identify key team members who can help drive and evangelize the serverless adoption. This is going to be things like training, pattern development, and really just being like that low-level ground force that's then going out to different teams, holding sessions about serverless, and really helping make this reality. And these key team members are going to be what we call at the very beginning, that serverless acceleration team, and what we're going to start building around that. If you don't have serverless experience already, you can look for a consulting partner that specializes in serverless adoption, serverless development, to help train and retool existing employees and help them grow. And that's also really huge for the overall success of the company, and the retention of employees is as a developer, I want to constantly be learning and being challenged and having new opportunities to learn. And serverless is almost this new thing that comes in. It solves a lot of these other problems. It makes us faster, which ultimately is saving engineering hours. And of course, as we know, the container cost or the server cost, typically the engineer cost outweighs those things, right? And so we optimize that part, but if we're not also optimizing the engineering side, then we're losing a fair amount of time. And so for a consulting partner, someone like Serverless Guru or other people that are out in the market, they can help you kind of jumpstart this process and make sure that you're pulling in the right templates, patterns, et cetera, and getting the proper training. So starting off with the strong foundation, the first thing we're going to be talking about is building your serverless acceleration team. And so for this, we're going to construct a working group that will help accelerate the rest of the organization, who will be building reusable infrastructure as code practices, processes, and so on, documentation around how to build these applications, and also just resources that we can find. Restructuring existing teams. So one big part of this is that as we're starting to think about how to develop in a serverless way, we're probably going to have to shuffle up some of the team structures. In more of traditional software development, as probably everyone's familiar with, you have these silos. And so you have developers, you have operations, and you have support and QA and so on. And in this way, we almost want to create these like smaller pods that have different components of everything that needs to take it from end to end. And because those abstractions have already been done, right? Because there's the databases now scale, like if you look at something like DynamoDB, it can scale horizontally and less to manage there, right? And so you think about that concept, you think about how much faster we're able to develop. Well, now we can have more people involved in that process to move faster, like end to end. And so that would look like operations, developers, QA, all kind of being wrapped up together. And also the transition from purely an operations side to more of like a DevOps side. So when it comes to doing this, how do you even go about adopting serverless, right? And so the thing that we want to look at is identifying a common service or use case. And so the question I usually like to look at is what service represents 80 to 90% of how other services are built in the legacy system or will be built from scratch, right? And so if we can identify, okay, we're going to be building a REST API, and that REST API is going to have a similar makeup to every other API that we build, then what we really need to focus on is laying a strong foundation for a REST API. Everything else that comes past that point will be more extra things on top of it. So the usage of maybe like queues and other things like that. But if we can identify that one case, that one use case, then we can empower a majority of the development to take place. And this gets us out of the stance of taking 10 developers and saying, okay, everybody start developing at once and start building serverless things. And some people have more experience than others. They'll do better. Other people have to rework their stuff, and it can be very chaotic. And so getting that kind of solid foundation, there's a thing that I like to say, which is slow down to go fast. And so we're slowing ourselves down to lay that solid foundation. But then once it's laid, then we can go fast and we end up making up for that time. And so how you can do this is you can draw a boundary around domains. So for instance, if it's like accounts, feeds, things like that, those could all be separate services. We could also develop reusable ISV patterns around this, as I mentioned. And at first, we want to keep it simple. We want to build a solid baseline, and then we can start expanding out in the future around things like caching and so on. And so what that looks like is if we have that overarching skeleton and we know that we can add stuff to it later, then we can have that able to be shared to the entire team. And they can say, okay, Joe needs a REST API to build his service. Okay, well, here's a template, Joe. Oh, I also need this other thing for caching. Okay, well, that's a separate template. And so now we've kind of broken those out into modular form. And those two templates together now create that entire service. And then when Kathy or somebody else comes later, they can all reuse that same thing again. And that makes all of us a lot more efficient. So getting to the common service blueprint. So we identified it, right? We said we want to build a REST API. And so now what we want to actually do is build or migrate that 80 to 90% common service. We're going to document the entire service migration and build process so it can be replicated, of course. We're also going to document the nuances of how your team builds services. And so if this was an internal serverless acceleration team, same thing here. You basically want to understand from the individual team perspective, where are they coming from when they say that they're going to build a serverless REST API, right? If they already have something that's existing, understanding the existing thing and then how it maps over is also very important, because those are the type of questions that developers are going to have as they get tasked with moving from a legacy system to serverless. We can also use all this knowledge to improve training material, and that kind of feeds back into that cycle, that feedback loop. So we use the service migration as well to build further leadership buy-in. And so as we start working on this, as we start showing progress, we can then show that to leadership. They can then give us either more funding, more resources, and or just help push from above, so that's now having the ripple effects down below. And so getting into employee training and retooling, this is also a core component of the serverless acceleration team. And so you're going to have things like the basic tool training. So this is like IC frameworks. For that, you can think about serverless framework, AWS SAM, things like that. The idea here is that we're going to condense years of learning into a happy path. And so typically with Serverless Guru, we like to stick with serverless framework. That's just kind of our preference. And we've been building with that for a long time. And so when we do these type of trainings, we show how to use serverless framework end to end. And that's also what the online course I mentioned previously, that kind of focuses on serverless framework. And so what's nice there is that we can say over 3 or 4 years of doing things, condense that down, and you kind of have you skip over a lot of the landmines. We also familiarize developers with common commands and usage. So with SAM or serverless framework or any other IC framework, they're typically going to have extra developer focused commands, right? So not just purely deploy, but also maybe like give me the last log of the Lambda function, print out my entire infrastructure as code template so I can see if there's any compilation errors. And then, and then we're also going to be demonstrating. That sounds like there might be extra audio coming through. Let's see. Okay, there we go. Close that down. Excuse me. Oh my gosh, I lost where I was. There we go. Okay. And so demonstrating service development workflow, testing, et cetera. That would also be part of this basic tool training. So once we have that baseline established of this is how you use it, this is how you build basic things, we have this blueprint, now we're kind of contextualizing it, right? So you can see what was done, we're teaching you how to do it, and then now it's more able to kind of be mapped together. Well, to take that pattern and really understand it, we need to do actually like a line by line review of it. And so not just like, now you understand serverless framework, we did a 2-hour session, or even if it was an 8-hour session, and then I'll take this pattern and replicate it. Really what we want to do as well is we want to go through the nuances of why we did what we did, why we organized the infrastructure as code the way that we did it, why we structured the folders the way that we did it. Because each one of those things has like some importance, because for the scalability of this, and creating standards, that's where we can kind of explain all this up front and save tons of downstream time. So when it comes to this, take the basic training one step further. We overview how the pattern was built, explain why things were built in that specific way. And then also we walk developers through how they can replicate the pattern themselves. So after doing this training, the basic tool training and the pattern training, what is the result of that? So as we mentioned, baseline has been established. Developers can replicate the common service, which is composing 80 to 90% of how other services will be built, which is actually a really huge thing. The wider team has more clarity on why the adoption is beneficial. So through that process of explaining that, you're basically learning the benefits as well at the same time, because that slow walkthrough of things, it'll start clicking to developers as they start seeing it, and they'll go, oh, okay, now I can map my existing knowledge to this new thing and see why this new thing has more benefits. Also, further service migrations, builds can now happen in parallel. So that's a huge thing. That's what ultimately we're setting up for, is we want all the people at this organization as the serverless acceleration team to basically allow them to go off and build independently. and build in parallel. And the last thing is less time wasted over recreating the wheel or having to rework the lowest hanging fruit. So what I mean by that is that if we're recreating the wheel, then we have 10 people all building a REST API. They're all going to build it slightly different. Some people have a better one, some people won't. The folder structure will be different, and so on. Mono repo, multiple repos. Like, it's important to get some baseline standards established up front because it's much more difficult to kind of rework those things later, in my experience. When you have somebody that already has those standards in mind, than to just kind of do the Wild West approach. Now getting into parallel service development. So now that everyone has the training and they're able to work independently, this is where we actually move quickly. So again, we slow down to speed up. We laid the foundation, we did the training, we did the blueprint, and now developers are off on their own, independently building. And so one thing that we could say here is that we let the development team now pick up services and start actually building independently. The development team can now multiply their efforts, and the serverless acceleration team closely monitors and is ready to help out as needed. So as developers are doing this, they're going to run into issues, and the serverless acceleration team is going to be there to both create edge case patterns, which we'll talk about later, as well as training videos and just answer questions and help steer people in the right directions. And while doing that, and this is very important, we want to make sure that the knowledge that's being shared is being shared in a public way. And so that's one thing that I often, I would say it's one of my pet peeves actually, is private chats. So I love having things in the public open because it's the most efficient way to do things. Because if you solve a problem, but you had to go through a private chat, and then that whole conversation kind of dies, right? Whereas if it was in a public and like in a share channel, then you can reference that and you can send it to other people later on. And so even if you don't have enough time to formally write an entire document or make a training video or make a template, even that conversation about that edge case, that can still be linked to if it's in the public, and other people can also read it at the same time. And one of the underpinning things is that it actually encourages more people to do that organically. And so the serverless acceleration team is also helping change that culture, right? And so the culture is is getting to the point where people are sharing knowledge openly, freely, saying, hey, I just worked on this cool thing. Hey, did you see this other feature? Hey, I hit this edge case. This is what I did for it. The serverless acceleration team kind of sparks that with the goal in mind of 2 months, 3 months later, people will start doing that on their own without being told to do it. And that's a really cool kind of butterfly effect. And we've seen that at Serverless Guru and at the clients we've worked with as well. Getting to tool development here. This is adding fuel to the fire with internal tool development. So this would be like building scripts to help development teams move faster. So if you see something that's like a very common thing, like for instance, I built a script a while back, maybe last week, which was for Cognito sign up, confirm sign up, and sign in. And so what that means is that when you're creating APIs and you have to authenticate that API with a JWT token from the Cognito service on AWS, what you need to do often is you need to have some type of front end to basically move through the auth flow to then get that JWT token, to then attach it to your request, to then test it. And so one way that we're doing it is that we have a script and you just basically run, npm run auth sign up, and then npm run auth confirm sign up, and then npm run auth sign in, and we get the JWT token back, and it takes about 10 seconds. And so we can sign up new emails through a bash script or through a Node.js script versus having to simulate a front end thing. And it's just things like that are really helpful. And it's about identifying those things in the development team, prioritizing it. Remember, slow down to speed up, right? It's going to take a little bit of time to build that script. But if you're now saving every developer across 10 developers, let's say 15 minutes every time they try to do this, and they need to do it 4 times a day, well, that ends up becoming a lot of time, right? Like that's 10 hours a day times a week, that's 50 hours. How much do engineers cost? And that's tens of thousands of dollars per month just in trying to get your authentication flow set up, which is important. So the goal is to identify any repeated processes, design automation to help them do it slightly faster, as mentioned. And then if you want to go to above and beyond, you then compile all these different scripts together into a CLI, and it could still be internal. And what that looks like is that now it's less of, hey, use this script, download this script, and then add it into your thing. And it's more of, hey, download the CLI, and then across all the services that we're developing, use the CLI to do things like the auth flow or anything else past that point. While this is happening, ongoing support is very key. And so we can see here, everything is still new. There's going to be roadblocks that get hit. The serverless acceleration team is going to provide ongoing support and identify areas for improvement. If everybody's running into the same type of things, it turns out no one understands API gateway caching. Okay, great. Let's create a training around it. Let's schedule a session with the entire team. Let's make sure that everyone has information about this topic. And then later on, it could be something else. And you just keep repeating that process until you grow the number of templates, training materials, all that stuff out over time. And so as well as when edge case patterns are identified, we're going to make sure to capture that so that we can then start building patterns for it. And of course, as issues are hit, we're going to document effectively so that across the org, developers can help themselves, keeping efficiency high. So that's kind of the thing, is that if there's like one source and that source is always giving the answer, it can create a dependency on that source, and we've seen this before. But if you're able to empower each individual developer on the team to then be able to seek that out themselves and know how to do that properly, then that's when you really start seeing exponential growth. Getting into edge case pattern development and training. So as they come up, they always will. Our whole goal as this acceleration team is to keep the developers focused, right? And by being focused, they're going to be doing the most enjoyable work that they need to do. And we're going to be able to just be that support role, right? So we say, to do API gateway caching again, I'm overusing the example, but to do that, let's actually create a pattern for it specifically. Let's show a couple different ways that you can actually do it. And then from there, let's give training to the team. And then as it gets further along, you can see here that we say uses each support and edge case to develop an internal serverless best practices playbook. And we've seen that other people do this as well. I think Lego.com has something like this internally for themselves, which is basically the overarching across all projects and different things they're doing. What are some of the baseline best practices for serverless development? We have that at Serverless Guru as well. And you can develop it at your company as well by seeing your specific tailored use case and then pulling in resources from the outside. And one cool thing I want to mention here too is that onboarding is often slow. And so it's a lot of things that happen with building serverless applications, a lot of moving parts, all those things. And so having documentation, having training sessions, sharing information in public, creating that type of culture, what it ends up doing is that it speeds up even onboarding. So new people can come in and they have all of these resources that they can just go down a rabbit hole on for a couple of days. And it's beautiful to see, because the second they get through it, you feel like they are a month ahead of where they normally would be. And it's only been like 3 to 5 days of them looking at it. All right, so we got through that successful serverless adoption, right? So what did we accomplish here? Talking through all these things. So let's say the legacy system, if we had one, it's been migrated to serverless, or if we were building from scratch, many new serverless services are now in production. One important thing to note there, which I didn't want to harp on in my talk because it was done so well previously to me, is that Epsagon is a really great thing to have when you get into production, and that production readiness is a very, very important factor. It's not so much talked about in my talk today, as I'm focusing more on the org side of things, but that's something that having the ability to see all that information at a very low level, at a very granular level, it does help improve, and it gives developers the insight that they need to be able to make those micro adjustments, and that has dividends downstream. Developers are also able to independently build new services. Knowledge is retained inside the team. Overhead and maintenance has been dramatically reduced. We're doing much less, and we're focusing more on the product. And the culture has been influenced to share knowledge and always think about ways to further optimize. Yeah. So what comes next after this, right? We got through it. So do we stop? No, we never stop. That's the point. If you walk away with one thing, it's that we never stop. The serverless acceleration team now can turn their attention towards internal processes that always get shelved. And that's one thing too, is that I know when I think about serverless adoption, I don't just think about adopting Lambda, right? Or DynamoDB. I think about a culture shift. I think about the realization of vision into reality, right? Serverless is a mechanism of that. And it's like a point in time where we can say, you know what, let's do things better, right? And so that's what this means to me. So we don't stop here. We now attack other areas that are causing inefficiency and slowing things down, and we improve those things. Also, before I get too worked up, the serverless acceleration team works with architects to design new serverless services. So maybe we want to jump into AppSync now, right? Maybe we want to do Event Bridge. And so this team can start working with the architects of different departments to then start building out patterns around this, and also helping map out how maybe not the low-hanging fruit that got migrated already, but maybe the more complex factors could also be moved to serverless. In that way, this team is also going to be building tooling, training to further improve developer workflows based on all this feedback as people are building independently. And of course, giving reoccurring working sessions to help train new hires and existing people in different ways of serverless. And so, yeah, on that note, let me wrap up. And as you can see here, this is the QA part of that. I'm going to stop the screen share here and then jump back to the other view. Perfect. Awesome. Jonathan, if you want to jump in.
Hey, yeah, thank you for that presentation, Ryan. That was great. I like that, the passion behind it. Not to get too worked up, but I like that. I like that passion. Yeah, so that brings us to the end of our 2 presentations. Thank you everyone who was here live for it. If you have any questions or any comments, concerns, or regrets, please leave them down below. We can answer them. While we wait for anyone to roll in for that, I have a couple questions for the hosts myself. Let's start off with with one for both of you. So guys, what is your advice to enterprises that are still reluctant to adopt serverless architectures? Or what would be your advice?
Yeah, so I can start with that one first. So enterprises that are reluctant to adopt it, I think, AWS reInvent's coming up in just a couple of months. So November, late November. So if you're open to figuring out, how are other people doing it, I think this year is going to be one of the biggest opportunities for serverless kind of hitting that main stage across all things AWS reInvent. And so just getting out there and talking to people, reading case studies about it, and looking at let's say a case study, I'll make it up, Carfax. I don't know if Carfax is 100% serverless, but you look at that, you read about what they did, what they accomplished, and you know what, maybe try to reach out to that person that wrote it from Carfax, and then maybe try to ask them a couple questions. And of course, there's a tons of article content out there, but one of the best sources that I've found for more of that long form would definitely be podcasts. And so we have the Talking Serverless podcast, but Jeremy Daly has one, Yan Kui has one, and there's a whole bunch more around serverless in the space. And so watching a few of those from, for instance, the VP of product or something from Lego.com, and hearing about how they adopted serverless, and then taking that type of information, that can already spark something there.
Yeah, just to add to that, I think Ryan covered most of the things there, but I definitely would be a +1 on the Jeremy Daly podcast. It's really awesome. And I would also say that I've seen most of our clients migrate from monolithic to serverless, and they start off with some pilot projects. So they don't deploy everything in production immediately. So they take a more cautious approach, some of them. And then once they see the success and how easy it is, then they move on to everything to serverless.
That's awesome, guys. Shout out to Jeremy Daly from me too. I just don't want to be the only one who doesn't shout out Jeremy Daly. He recently named our COO, Joshua Proto, his Star of the Week in his latest newsletter. So go check that out too. Why not just call it all out? That's awesome. Chinmay, could you explain the value propositions of Epsagon and the customer pain points they address?
Yeah, sure. So one of the value propositions of Epsagon is we integrate really well with cloud vendors. So for example, with AWS, one of the pain points that I've seen most of the customers have is not seeing the entire end-to-end trace or service map. And Epsagon does a great job of integrating AWS services in it. So you can actually get a holistic view of the architecture. The payload information that I mentioned in my presentation is also very critical. I've seen a lot of customers using the payload information to debug more efficiently and troubleshoot and get to the root cause of the problem. And then finally, all the benefits of distributed tracing that I mentioned have been implemented in Epsagon. So definitely recommend checking us out. We also have a free trial.
Awesome. Yeah, definitely check out Epsagon, everybody. You can also find them on Twitter at Epsagon and visit their website, epsagon.com, to learn more about their offerings and how their company can help you monitor containers in your serverless environment. So definitely check them out. You know, this is not a serverless specific question, guys, but I'm curious since Chinmay did mention enjoying going to different restaurants. You know, what's the best thing you've ever eaten out and about? Traveling or even at home? What's like either a comfort food or something that you even just remember having that you're like, oh man, I would have that again? This is for both hosts, so feel free to jump in if you guys have a answer to that.
I can go first. One of my favorite places. So as I mentioned to you, Jonathan, I used to live in Berkeley before. So one of my favorite restaurants out there is called Cheeseboard. Big shout out to them. It's a cooperative restaurant, so they just have like one pizza per day, and it's really tasty. Ryan, I'm actually going to Puerto Rico next week, so hopefully you have some recommendations from there.
Yeah, awesome. Well, my dish is it's more of my comfort food now. It's a mofongo. So mofongo is like a plantain dish that's almost like a mashed up plantain. They'll stuff it with like shrimp or some type of meat or just vegetables. And I eat mofongo all the time when I go out here in Puerto Rico because like that's like the traditional Puerto Rican dish. So hopefully that buys me some brownie points for anybody that's watching this from Puerto Rico. Awesome. And yeah, when you come down, yeah, let me know. I can send you a few of the different places that I like to go to down here. Awesome.
Well, you make me jealous, you guys. I love traveling and I love food. So, you know, Cheeseboard, a man after my own pizza loving heart. Thank you, Chinmay. I love the shout out to that too. Yeah, Cheeseboard's great, guys. And Ryan, that sounds delicious. I don't know. I have never had any traditional Puerto Rican food, but I mean, I feel like I need to now. Yeah, that was great. All right, my last question for you two guys are, how do you envision the serverless landscape evolving over the next 5 or even 10 years?
Yeah,
Ryan, I'll let you take that.
Okay. Yeah, so this one is often like something that I constantly try to understand this point, and it's, you know, it's hard to obviously understand the future if we could fully, you know, but I definitely think that the mainstream has caught up some level with serverless, and we're going to see that with the reInvent conference. That's my belief. And so with all the talks that are happening there, with all the different platforms, with companies like Epsagon that have been pushing the space for a long time now, and there's tons of other companies now that are starting up, not just in monitoring and CI/CD, developer workflow, and we're just seeing a lot of maturity happening across all areas. And so I think those things and those use cases and people talking about it and creating content, we're going to start seeing a lot of growth happen in the field of serverless development. And yeah, I would say, you know, maybe it's not like a linear line, but, you know, I think we're going to see a lot of growth happening in the next 5 to 10 years.
Yeah, I completely agree with that. Yeah, nothing to add there.
Well, that's awesome. That's very exciting. Looking forward to the growth of serverless. You know, it's been something that I've been learning a lot about in the last year, and it seems like, you know, people who are in it since like 2016, you know, the grizzled veterans of it. I love going on Twitter and seeing everyone's opinions on it. and just seeing the growth of it has been really exciting. And it feels like it's been so electric for, ever since it was put onto the market, so that's great to hear.
Absolutely.
All right, let's see if there are any questions or Q&A or anything additional, any other points. Is there anything that you two would like to leave off on, or any last any points you guys like to bring up?
Chinmay, do you have any thing to promote on your end, or anything going on?
Not much. I'll be speaking at a Kong conference, Kong Summit next week. So feel free to check me out there. Apart from that, just check out Epsagon. And if I like to just say that serverless seems very intimidating at first, but once you get onto it, it's pretty easy and it's easy to manage. So definitely you should go and adopt serverless.
Absolutely. Yeah, and I think, on my end, probably just more of these webinars coming up, cool things happening in the serverless space, more content, always exciting. If anyone's coming to reInvent, I'll be down there. So let's grab a cup of coffee or something. And yeah, I think we're probably good to wrap, Jonathan.
Awesome. Well, thank you to everyone who attended. In about a week, you should receive an email with this recording. Also, be sure to keep up with us in our upcoming events through our Twitter at Serverless Guru. Also, please give some love to our co-hosts, Epsagon, through their website and their Twitter, like I said before. With that being said, have a great day, everybody, and see you on the next one.
Thanks everyone. Bye.
Thank you, bud.